Hello and welcome back to video lecture on R microcontroller and embedded system. In today's video, we are going to cover further topics of Module 3, embedded system components. Here in this video, we are going to discuss sensors, actuator, I/O subsystem, some of the examples for the input devices and output devices. Let me begin with the first topic, sensors and actuators. Sensors and actuators are the transducers. Transducers are those things that convert energy from one form to the another form. The sensors are the transducers which converts a physical quantity into electrical quantity in terms of voltage or the current. Whereas actuators are the opposite of sensors. It means that they are also transducer that convert electrical or mechanical quantity in terms of energy, voltage or current into a physical quantity. Sensors are always connected to the input port to which input device is connected. Any change in the input device will be sensed by the sensor and will be given to the core of the embedded system in terms of voltage or current. Whereas actuators are connected to the output ports and those output ports are connected to the output devices in an embedded system. Then we have a I/O subsystem. The interaction of embedded system with the external world is taken place with the help of these sensors and actuators. The sensors may not be connected directly to the input ports. Instead, they may be connected to the embedded system via the signal conditioning and translating systems such as a ADC, that is analog to digital converter, and optocouplers. Let us discuss some of the output devices. The first one is light emitting diode, abbreviated as LED. It is one of the important output device. It is used for the visual indication. It is used for indication of the status of various signals or the situation. For example, indicating the presence of power conditions like device on, battery low, charging of battery, for battery operated handheld embedded devices. What is this? This is a PN junction diode that contains anode, the positive terminal, and a cathode, negative terminal. The anode of it should be connected to the positive terminal and cathode of it should be connected to the negative terminal of the power supply for its operation. When we make this connection, current flows through the LED, that is from anode to the cathode. LED must be limited to a value below the maximum current that it can conduct, and that flow of the current through the LED can be limited with the help of resistor connected in series between the power supply and the LED. Look at the diagram wherein we have shown the LED. The anode terminal of the LED is connected to the VCC with the resistor R, and cathode is connected to the ground. Whenever that VCC plus 5 volt power supply is given, with the resistance, a limited current flows from anode to the cathode, turns on the LED. And there are two types of LEDs interfacing to the microprocessor or microcontroller. That is, anode of the LED is connected to the port pin and cathode to the ground. And port pin acts as a source of the current and LED can be turned on and the port pin is at logic high. And another way of interfacing is cathode of the LED is connected to the port pin and anode of the LED is connected to the VCC. The port pin acts as a sinking the current and LED is turned on and the port pin is made at the logic low level. Then next type of output device is 7 segment display. As the name itself says, the 7 LED segments are connected in some order or in the sense format for displaying alphanumeric numbers. Alphanumeric in the sense we can display all the decimal numbers from 0 to 9 and we can display some characters, not all, only few. Actually, this 7 segment display consists of 8 LED segments. Out of those 8, 7 LED segments are used to display the alphanumeric characters, whereas 1 LED segment is used to turn on the decimal points. Look at the figure which is shown in the right hand side of the image. There are 8 segments A, B, C, D, E, F, G and DP, and the segments A to G are the 7 segments where DP is the decimal point segment. For example, to display number 4, I have to turn on the segment B, C, F and G. Similarly, if I want to display the number 3, then I have to turn on A, B, C, D and G. Similarly, any number from 0 to 9 can be displayed by turning on corresponding LED segments. In the 7 segment display, there are 2 types. One is the common anode and another one is the common cathode. Look at the diagram. The configurations are shown. In the first one, common anode LED display, all the anodes of 8 7 segment LEDs are connected commonly to the anode, whereas cathodes are kept open, and these cathodes can be connected to the port pins. Whenever any port pin is made 0, the current flows through the anode to the cathode of that particular LED and that LED turns on. Whereas in the common cathode LED display, cathodes of all the LED segments are connected commonly to the ground, whereas anodes of these LEDs are left open, and these anodes can be connected to the port pins of the processor or controller. Whenever I make the anodes of these LEDs 1, current flows from anode to the cathode, hence corresponding LED turns on. These 7 segment LED displays are used in low cost embedded applications such as public telephone, call monitoring device, point of sale terminals, etc. Then we'll discuss next type of device called as Optocoupler. It is a solid state device used to isolate 2 parts of a circuit. It is a combination of an LED and a phototransistor in a single package. In electronic circuits, it is used for suppressing interference in the data communication, circuit isolation, high voltage suppression, simultaneous suppression and signal intensification. Optocouplers can be used in either input circuits or an output circuit as shown in the figure. Look at the first image, wherein left hand side I have a LED and that is connected to the IO interface, means input or output interface, whereas other side of that contains a phototransistor and other side of that is connected to the input or output interface. So we know the working of transistor. Whenever we give some current to the base terminal, transistor turns on, current flows from its collector to the emitter. Here it is a phototransistor. It means that whenever a light falls on base terminal of that transistor, the transistor turns on and there is a current flow between its collector to emitter terminal. The same optocoupler which I have shown in the left hand side is used in a circuit as a input as well as output. Look at this diagram. See here, the collector of the phototransistor is connected to the VCC via resistor. It means that when VCC is not given and LED is off, that time the transistor is off, port pin is getting the value 1. The moment LED turns on, the transistor turns on and there is a current flow between collector to emitter, hence port pin becomes 0. This is the working at the input side. Let me explain the working of it at the output side. See here, anode of LED is connected to the VCC via resistor. It means that whenever I give plus 5 volt to the VCC, LED turns on and it turns on the phototransistor in turn, then current flows from collector to the emitter of that. Then I will move on to the next topic called as a relay. What is the relay? It is an electromechanical device which acts as a dynamic path selectors for signals and power. It contains a relay coil made up of insulated wire on a metal core and a metal armature with 1 or more contacts. Relay works on the principle of electromagnetic phenomena. When a voltage is applied to the relay coil, current flows through the coil, which in turn generates a magnetic field. The magnetic field attracts the armature core and moves the contact point. The moment of the contact point changes the power or signal flow path. Relays are available in different configuration: single pole, single through, normally open; single pole, single through, normally closed; single pole, double through. Look here, in the single pole, single through, there is only one path for the information flow. In the normally open, normally in the sense at the beginning they are open. When the relay coil is energized, the relay that open is becomes closed. Whereas in the normally closed single pole single through configuration, the circuit is normally closed, and when the coil is energized and circuit becomes open. Whereas in the single pole double through, there are two paths for the information flow, and those two paths are selected based upon the energizing and de-energizing relay coil. Relay is normally controlled using a relay driver circuit connected to the port pin of the processor or controller. A transistor is used to build the relay driver circuit along with the freewheeling diode, and this freewheeling diode is used for voltage produced in the opposite direction when the relay coil is de-energized. Look at the diagram. From that it will be clear to you where we have connected freewheeling diode. See here, whenever current flows through this relay coil, that other side of the relay gets connected. When the relay coil is de-energized, the current flows in the opposite direction. So when current flows in the opposite direction, it should not damage the power supply VCC. Just to avoid that, a freewheeling diode is connected there. Most of the industrial relays are bulky and requires high voltage to operate. We are using special relays called reed relays for the embedded applications, and that requiring switching of low voltage DC levels. Next is the piezo buzzer. It is a piezoelectric device. The piezoelectric device works on the principle of mechanical things and the electrical things. It means that whenever we apply mechanical input to it, it gives the electrical output, or whenever we give electrical input to it, it gives the mechanical output. And this piezoelectric buzzer is used for generating audio indications, and it contains a piezoelectric diaphragm which produces audible sound in response to the voltage applied to it. There are two types of piezoelectric buzzers: self-driving and external driving. In a self-driving, it contains all the necessary components to generate sound at a predefined tone on applying the voltage. Whereas in the external driving, it supports the generation of different tones, and a tone can be varied by applying a variable pulse train to the piezoelectric buzzer. And this piezoelectric buzzer can be directly interfaced to the port pin of the processor or control. Next is the push button switch. Is an input device, comes in two configurations: push to make and push to bake. In push to make configuration, the switch is normally in the open state, and when the push button is pressed, and it makes a circuit contact. Whereas in push to break, the switch is normally in the closed state, and when we press or push the button, it breaks the circuit contact. Push button is used for generating a momentary pulse, for generating reset and start switch, and generating the pulse generator. Normally it is connected to the port pin of the processor or controller. Depending on the way in which the push button is connected to the controller, it can either generate a high pulse or a low pulse. As shown in the figure. Look at the left hand side figure, where push button is connected between the ground and VCC. In between VCC and switch, we have a port pin and register. It means that when the push button is not pressed, port pin gets the value of VCC, that is logic 1. When the switch is pressed, that VCC gets the path for the ground all the power goes to the ground, hence the value of ground logic 0 goes to the port pin. It means when switch is pressed, low is going to the port pin. Other side, we have shown the similar figure. Difference is that we have interchanged the position of resistor and the switch. It means that when switch is open, port pin gets the value of the ground, that is logic 0. When switch is pressed, port pin gets connected to the VCC and it gets the value of VCC, that is plus 5 volt logic 1. So these are some of the devices of input and outputs. Remaining topics I will cover up in the next